When I began creating the world that became my world of Babel, I started by building a star and some planets to go around it. Now, I'm not mathsy, so I wouldn't have had a clue of where to start without Artifexian's videos on building planets and putting them into orbit. In fact, as you'll soon see, I did screw it up, despite trying to follow his advice. But for now, friends, you're probably wondering how one goes about building imaginary celestial bodies. The answer is maths. Lots and lots of maths. This is Domum, or Japudor. It's a K-type main sequence star 0.65 times as massive as our Sun and about 0.8 times as hot. It's the same type of star as Epsilon Eridani, but that probably means nothing to the average person, so let's get into the details. Domum is younger than our Sun, making it cooler, smaller, dimmer, and less massive. This has some implications. For one, Domum is more orange than our Sun, which is quite yellow. This means the skies on planets orbiting Domum will be a lighter, more pastel blue than the sky on Earth. It also means planets on habitable worlds will either be deep indigo, evolved to absorb the most sunlight they can as efficiently as possible, or they'll be a warm, coppery orange, evolved to reflect the potentially harmful amounts of orange light put out by the Sun and absorb other wavelengths instead. Also, habitable Earth-like planets orbit closer to Domum than Earth is to our Sun, so Domum seems bigger in their skies than the Sun is in ours. But that's enough about the Sun. I want to talk planets. There are 13 of them, 6 terrestrials, 5 gas giants, and 2 dwarves. We'll start close to Domum and work our way out. So, with no further ado, meet Domum Kappa.
Wait a minute, hold on.
I know it makes no sense to name my first planet after the 10th letter of the Greek alphabet, but I'll explain later. For now, let's talk numbers. Domum Kappa has 0.435 times the mass of Earth, but only 0.42 times the radius. Again, that probably doesn't mean much to the normal person, but it's a bit weird, because this little planet is 5.8 times as dense as Earth, and its gravity is 2.5 times as strong. How is that possible? Well, if you crack this sucker open, you'd find the reason inside. Domum Kappa's volume is dominated by a huge iron core, proportionately far larger than even Mercury's. This gives it powerful gravity, a chemically reducing atmosphere, and a strange, desolate environment. You'll find fields of glassy whitish stone that you might mistake for quartz, but are really diamond. There are seas of iron and nickel carbonyl, and the planet is riddled with active volcanoes.
It's hell in there, it's horror. You have to be a certain type of person to survive that.
The atmosphere contains oxygen, ozone, and nitrogen, but volcanoes also pump it full of carbon dioxide, water vapor, sulfur dioxide, carbon monoxide, and traces of methane and hydrogen sulfide. God, that's a cocktail. My chemistry might be a bit off, but volcanic methane and atmospheric ozone should react and form hydroxyl radicals. These could allow volcanic sulfur dioxide to oxidize into sulfuric acid, and hydrogen sulfide could also oxidize into sulfoxylic acid. If I'm right about this, Domum Kappa has conditions like Venus. Opaque, acidic storm clouds trap heat in and reflect light away, making it the brightest object in other worlds' night skies, like Venus is to Earth. And thanks to all the ozone, methane, and sulfur in the atmosphere, the sky is a dull, hazy, orangey reddish color. But I could also be wrong about these reactions, which is quite likely because I'm not a chemist. Domum Kappa orbits 0.189 AU from Domum, less than 1/5 the distance from Earth to the Sun. The local year is about 37 Earth days. Domum Lambda is another small rocky planet with another big iron core. It's nowhere near as big as Domum Kappa's though, making the planet's environment less interesting, but also mercifully less hellish. It has just under 1/3 the mass of Earth and just more than half the radius. It orbits 0.358 AU from the Sun, and the local year is about 97 Earth days. The third planet in the system is an Earth-like planet named Domum Alpha.
What?
And it's at this point that I admit this isn't my first attempt at making this solar system, nor at writing this video. The original Domum system only had 5 planets: Domum Alpha, Vita, Gamma, Delta, and Epsilon, named for the first 5 letters of the Greek alphabet. Simple, right? But then, as I was doing the bare minimum research to make sure it made sense, I found an Artifexian video wherein Edgar noted some things. Firstly, no 2 planets should orbit their star within 0.15 AU of each other. Secondly, planets should be spaced logarithmically, which sounds super sciencey, and I guess it is since I don't know how to explain it, but I promise it's pretty simple. Just watch the video I'm talking about, I've linked it. And thirdly, I knew that solar systems with low solar mass often have high planetary mass, and vice versa. Since Domum has less mass than our Sun, it should be orbited by more planets. Basically, I'd screwed up my maths.
It's what the kids call epic fail.
So I rebuilt the system. I started by shifting the existing planets' orbits around to their current positions so that they made sense. Then I filled in the gaps with new planets. This meant lots of newbies further out, but it also meant putting 2 planets between Domum Alpha and Domum itself. But what would I name these? In a perfect world, they'd be Domum Alpha and Domum Vita, but I'd already been calling my Earth-like planet Domum Alpha for months, and I didn't want to change it in all my notes. So I called these new planets Domum Kappa and Domum Lambda, and called it a job done. Now the order goes Domum Kappa, Lambda, Alpha, Vita, Gamma, Delta, Epsilon, Zeta, Eta, Theta, Iota, Psi, and Omega.
Child.
Okay, I guess Psi and Omega don't make much sense either. They're the 2 dwarf planets though, so I thought it was okay to use the last 2 letters of the Greek alphabet because they're not like other girls, nya?
Anyway, so
Domum Alpha is 0.79 times the size of Earth and has 0.67 times the mass. It orbits 0.53 AU from Domum, a bit more than half the distance between Earth and our Sun. Its average temperature, though, is about the same as Earth's. I did mention habitable worlds orbit closer to Domum than Earth is to our Sun. A year on Domum Alpha is 174.8 Earth days, and the local day is ever so slightly longer than an Earth day, but only by an average of 40 seconds, which is close enough. Another fun detail about Domum Alpha is that it's 43 million years younger than Earth. That might sound like a lot, until you remember that 4.6 billion minus 43 million is 4.557 billion. I'll go into more detail about Domum Alpha's atmosphere and geography another time, but for now, suffice it to say that it's pretty Earth-like. Domum Alpha also has a moon. Wonderful. It's called Alpha Luna, or Gaui. It's a little more than half as big as our moon, about 1/6 as massive, and it orbits 380,000 kilometers from the planet. A full lunar cycle takes about 18.4 days. Dormum Alpha is where we'll be spending most of our time in the world of Babel, since it's the only planet in the system that's habitable for carbon-based life. Still, it's worth having a gander at the other planets orbiting Dormum. At least, I hope it is, because I put a lot of work into them. Dormum Vita is a small rocky planet, like Dormum Lambda. It has a little more than half Earth's size, less than a third the mass, and it orbits 0.747 AU from the Sun. A year on Dormum Vita is about 292.5 days. The fifth planet is Dormum Gamma, and I think it's pretty fascinating. It's big, rocky, and about 3/4 covered by glaciers and ice sheets. Were it closer to the Sun, it'd be an Earth-like planet, just like Dormum Alpha, but with no major moon to create tides and stabilize its axial tilt, and temperatures too cold for liquid water, it can't support carbon-based life. With 1.25 times the size of Earth and twice the mass, it's far larger and more massive than Dormum Alpha. It orbits 1.188 AU from the Sun, and a local year takes about 586.6 days. Dormum Gamma also has a moon called Gamma Luna. It's a minor moon, which means it's not large or massive enough for its own gravity to pull it into a spherical shape, so it looks more like an asteroid than anything the average person would call a moon. It's like the moons of Mars. It orbits about 725,000 kilometers from Dormum Gamma and completes a lunar cycle once every 50 or so days. Dormum Delta is the last terrestrial planet in the system. It has no continents and is covered in ice sheets and glaciers like a giant snowball. It's 0.85 times the size of Earth and 4/10 as massive, getting its super low density from its thick ice layer. Being mostly covered in ice, it reflects light like Dormum Vita, which makes it very bright and also very cold. It orbits 1.913 AU from Dormum. Were it in the system's habitable zone, it'd be a water world, and the local year is about 1,199 days.
Oh, whoa, what's this? An asteroid belt? It sure is.
The Delta Epsilon belt is the first asteroid belt in the Dormum system, named for the planets either side of it. It begins roughly 2.096 AU from the Sun and stretches to about 2.27 AU from it, but these are just general parameters. It's the smallest of the system's 3 asteroid belts, with an edge-to-edge width of 0.348 AU. It's not much smaller in diameter than the next belt, but it is less than half the width from edge to edge. By the way, don't believe what Hollywood tells you about asteroid belts. They're much sparser than we tend to think, and it wouldn't be that chaotic to pilot a spaceship through one. Not that I have any personal experience in the matter. The next planet is Dormum Epsilon, the system's first gas giant. It's about 2.8 times as massive as Jupiter, but it has the same radius as Jupiter, which makes it super dense. You know how Earth's gravitational acceleration is 9.8 meters per second squared? Yeah, well, Dormum Epsilon's is 70.16 meters per second squared.
We just went down.
Dormum Epsilon orbits at about 2.75 AU, and the local year is about 2,072 days. And how could we ignore those rings? Hey, how are you, Gorge? Dormum Epsilon has 6 rings and 34 moons. I'm not going to go into tons of detail about them because that would be agonizing, but here are the basics. 4 of the gaps between the rings are carved by tiny moons, and the 5th one is maintained by some gravitational chicanery by one of the larger moons that orbits further out. Beyond the rings, there are a couple of minor moons that share an orbital path. They're girlfriends, obviously. 4 major moons orbit further out, between 279,000 and 1.48 million kilometers from the planet. There are also 6 minor moons in orbital resonance with the 1st and 4th major moons. That is, they more or less share the major moon's orbital paths due to funky interactions between their gravities. Finally, 8 minor moons orbit on steep angles between 1.5 and 2.2 million kilometers from the planet, and 10 retrograde minor moons orbit between 3.3 and 3.8 million kilometers from it. Also, because Domum Epsilon is so damn massive, there are a whole bunch of asteroids that orbit the Sun in gravitational resonance with it. In fact, there are more than 11,000. Some orbit in an arc in front of Domum Epsilon, some orbit behind it, and some orbit on the opposite side of the Sun to it. There's another asteroid belt, the Epsilon Zeta belt, between Domum Epsilon and Domum Zeta. Don't worry, I'm not doing the catgirl voice again. It stretches from about 2.9 to 3.8 AU from the Sun, and is about 0.87 AU wide from inner to outer edge. Domum Zeta is a big fluffy cloud of a planet with a huge radius but low mass, which gives it low density and weak gravity. With 1.78 times the radius of Domum Epsilon and nearly 25 times that of Domum Alpha, it's easily the largest planet in the system. But it has barely more than half Jupiter's mass, and so only about 9% of its density. Domum Zeta orbits about 4.75 AU from Domum, and the local year is about 4,700 days. Domum Zeta has 36 moons. The first 10 are small, irregularly shaped, like Gamma Luna or the moons of Mars, and orbit between 115 and 145,000 kilometers from the planet. The 6th and 7th moons are girlfriends who share an orbit like the 5th and 6th moons of Domum Epsilon. Aww. 2 of Domum Zeta's major moons are rocky and 4 are icy. They orbit between 497,000 and 1.86 million kilometers from the planet, and they have some orbitally resonant minor moons too, 7 to be exact. The rest of Domum Zeta's moons are small, distant, and orbit on steep angles. There's one at about 2.5 million kilometers, 7 orbiting retrogradely at about 2.87 million kilometers, and another 5 at about 4.8 million kilometers. Our next planet is Domum Eta, the 3rd gas giant in the system, but to be honest, following the super dense Domum Epsilon and the gigantic Domum Zeta, it's kind of the first normal gas giant of the lot. It's about a third as massive as Jupiter, about 83% as big, and at 11.158 meters per second squared, its gravity is so weak that it's almost Earth-like. Domum Eta orbits 8.14 AU from the Sun, and the local year is about 10,521 days. Domum Eta only has 23 moons, so by gas giant standards, it's basically single and ready to mingle. Oh god. The first 3 are minor moons, orbiting between 99 and 132,000 kilometers from the planet. Then its 5 major moons can be found between 202 and 873,000 kilometers from the planet. And finally, 15 minor moons race around between 33.68 and 33.97 million kilometers from the planet. Domum Theta is another gas giant. It's like Domum Eta in being mostly ordinary, except it orbits on an inclination of 6.17 degrees, which is quite steep for a gas planet. It's the smallest gas giant yet, with about 5% of Jupiter's mass and a little over a third its size. In fact, its gravity is weaker than Earth's at 9.038 meters per second squared. It orbits 15.263 AU from the Sun, and the local year is just over 27,000 days. Dormum Theta has 27 moons, and you know what? I can't be bothered to talk about them much.
Bored as she.
Basically, there are 8 minor moons, then 5 major moons, some orbitally resonant minor moons, and some more distant minor moons. If you want to read more about them for some reason, you can pause the video. The system's last gas giant is Dormum Iota, a type of gaseous planet known as a mini-Neptune or gas dwarf. It has a rocky core, a thick icy mantle of ammonia and some water, oceans of liquid ammonia, and a very thick hydrogen-helium atmosphere. It gets its mini-Neptune name because it's far smaller than Neptune but has a similar internal structure. It doesn't even have 4 times the mass of Earth, and it barely has more than 5 times the radius. Its gravity and density are super low too, and it orbits almost 26 AU from Dormum. The local year is more than 59,000 days. Dormum Iota has 18 moons, and its moon system is structured like those of the other gas giants. There are 9 major moons pretty close to the planet, between 29,000 and 2.4 million kilometers from it, and a couple major moons between 13 and 14 million kilometers from it. There are a few more irregular minor moons further out, like way further out, between 60 and 63 million kilometers from the planet. Oh, whoa, and what's this? 2 of those minor moons are co-orbital. That makes 3 pairs of co-orbital moons in the Dormum system, and friends, if that isn't lesbian rights, then I don't know what is. The end is near now, I promise.
The end is near. The end is near.
The post-Iota belt is the Dormum system's 3rd asteroid belt, and by far its largest. Like the other belts, it's made up of small bodies left over from when the system formed billions of years ago. But while those inner belts are rocky, this one is more icy. It's home to the 2 dwarf planets I mentioned, Dormum Psi and Dormum Omega. The post-Iota belt begins roughly at the orbit of Dormum Iota, nearly 26 AU from the Sun, and ends at about 32.5 AU. Most of its mass is concentrated at its inner edge though, and its density drops off further out. Dormum Psi is the smaller and icier of the 2 dwarf planets. It has 0.03% the mass of Earth and about 9% the size, with a radius of 580 kilometers. It orbits over 28 AU from Dormum, and the local year is nearly 70,000 days. It's orbited by 3 or 4 moons? You'd think that I, if anyone, would know how many moons my little imaginary planet has, but I don't. I just couldn't be bothered to do the maths to make those moons. I mean, most of the Dormum system is a backdrop for the work I'll be doing on Dormum Alpha anyway. It's already really detailed, and I'm proud of that. If I weren't, I wouldn't share it. But I never thought that the moons of distant dwarf planets were that important.
Okay.
Dormum Omega is the last planet in the system, and it's larger and rockier than Dormum Psi. It's so huge, in fact, that it has more than 1% of Earth's mass. Wow! Its radius is gigantic too, at about 15% of Earth's, or about 950 kilometers. It orbits nearly 33 AU from Dormum, and the local year is over 85,000 days. It has 7 or so moons, which I also didn't care enough to actually create, so we'll just say that they're there and be done with it. And finally, we have the Dormum Border Cloud, which is more or less the same as our solar system's Oort cloud. It's a massive cloud of mostly icy objects surrounding the Dormum system, orbiting between 1,300 and 130,000 AU. So, friends, let's take a look at this star system. We have a small, dim, orange star, a super dense, iron-rich hellscape of a planet, a small rocky planet, an Earth-like planet and its moon, another small rocky planet, a big frozen Earth-like planet and its little baby moon, and an icy snowball planet. Beyond the first asteroid belt, we have a massive gas giant with its moons and rings, then another asteroid belt and a huge low-density cloud of a gas giant, a couple more ordinary gas planets, and a delightfully interesting gas dwarf. At the outer reaches of the system, there's another asteroid belt, like our Kuiper belt, that's home to a couple dwarf planets, and beyond that, there's a great big cloud of little chunks of ice. Pretty neat, right? Here are some size comparisons so you can get a sense of scale. Hit pause if you want to have a look. Maybe I should have mentioned that the other graphics aren't to scale? But anyway, welcome, friends, to the Dormum system. Thank you for watching if you made it this far. As for the system's position in the galaxy, if it's even in our galaxy, or if it's even in our universe, I don't know, and it doesn't matter. Next time, we'll explore the geography and ecology of Dormum Alpha, the planet on which my world of Babel is focused. Anon, friends. Here's the real question, though. Is Dormum Epsilon dummy thick because it's supermassive, or is Dormum Zeta dummy thick because it's really big? Or are they both dummy thick, and is it juvenile and unwise of me to pit two queens against each other? This is so stupid, just click away for your own sake.